Prudent Scholars in association with Goa Headmasters Association.
Welcome students for learning of science for standard 10th. Today we will continue with the chapter 1, Chemical Reactions and Equations, session 2. In the previous session we have learned about chemical reactions, its characteristic, chemical equation and how to balance a chemical equation. I hope all of you remember that. Students, there are so many chemical reactions in chemistry. How are we going to learn all these reactions? Don't worry. All the reactions are classified into different categories. So, in this session, we are going to visualize the different types of chemical reactions. There are mainly 4 types of chemical reactions. 1. Combination reactions, decomposition reactions, displacement reactions and double displacement reactions. So, chemical reactions are classified mainly into 4 types: combination, decomposition, displacement, double displacement. Let us see these types one by one. First, combination reaction. The name itself suggests something which combines to give something. Here, have a look at these chemical equations on the slide. When you study these chemical equations carefully, can you notice that there is something common in all these 3 chemical equations? Can you notice what is common? Yes, all these 3 chemical equations has got only one product. If you look at the right hand side, the product, there is only one product in all these 3 chemical equations, whereas the reactants, there are 2 reactants. Such reactions in which 2 or more reactants combine to give a single product is called combination reaction. Let us consider A and B are the 2 reactants. They combine to give a compound which is called AB. So, here the key word for you to remember about combination reaction is nothing but just one product. So, next time when you look at a chemical reaction, just look at the product side. If the product is just one, it is a combination reaction. Reactant can be 2 or more. So, 2 or more reactants combine together to give a single product is called combination reaction. I hope it is clear for you. The key word to remember in combination reaction is only one product. Let us move on to the second type of chemical reaction. Decomposition reaction. What is the meaning of the word decompose? Break apart. Here, consider the reactant AB. It is a compound. Decompose to give the products A plus B. Look, there are 2 products. There is a plus sign between them. But go to see the reactant is just single. Don't you feel it is opposite to the combination reaction? What have you seen in combination reaction? The product, there was only one product. But in decomposition reaction, there is only one reactant. So, combination reactions are said to be opposite of decomposition reaction. So, let us define decomposition reaction. The reactions in which a single compound breaks up into two or more simpler substance. So, when you look at a reaction, chemical equation, when you see in the reactant side, if there is only one reactant, you can predict that it is a decomposition reaction. Product may be two or more, but the reactant is just one. So, the key word to remember in decomposition reaction is only one reactant. Let me make myself clear to you again. In combination reaction, there is only one product, whereas in decomposition reaction, there is only one reactant. So, combinations and decomposition reactions are opposite to each other. So far, we learned about two types of reactions, combination and decomposition. Now, we have to learn something more about decomposition again. Decomposition reaction to take place, to occur a decomposition reaction, we need to supply energy. So, energy can be in the form of heat, in the form of light, or in the form of electricity. Once again, decomposition reactions can take place in three ways. 1. By absorbing heat. 2. In the presence of light. 3. With the help of electricity. Let us see one by one how the decomposition reaction takes place by absorbing heat. In this diagram shows what happens when lead nitrate is heated. Lead nitrate is a compound. This lead nitrate is taken in the test tube. It is white in color. You will be doing this experiment in your practicals once the school reopens. So, lead nitrate is taken in the test tube. It is heated with the help of burner, and while heating, the lead nitrate decomposes, breaks apart to give three products. Which are those three products? Lead oxide, nitrogen dioxide, and oxygen. This nitrogen dioxide gas is a toxic gas and it is brown in color. So, these brown fumes which you can see are nothing but the fumes of nitrogen dioxide. So, heating of lead nitrate is an example of decomposition reaction. Here, the decomposition reaction takes place with the help of heat. So, we call this reaction as a thermal decomposition reaction. Thermal word is connected to heat. When decomposition reaction takes place with the help of heat, we call it as thermal decomposition reaction. So, next time when you hear thermal decomposition, what word should be there in your mind? Heat. You know what is decomposition? Breaking apart into many products. So, when this decomposition takes place with the help of heat, we call it as thermal decomposition. Is it clear? Next, I told you decomposition reactions can takes place by three ways. First is we already learned thermal decomposition. Next, decomposition reaction can take place with the help of electricity also. This diagram depicts the electrolysis of water. What do you mean by electrolysis? You know, water is composed of hydrogen and oxygen. When electricity is passed through acidified water, what is the meaning of the word acidified? We put 2-3 drops of sulfuric acid in this water to make it a good conductor of electricity. So, that is called acidified water. So, when electricity is passed through acidified water, the water is decomposed to form hydrogen and oxygen. The hydrogen and oxygen is collected by the downward displacement of the water in the test tube. When you see, the volume of hydrogen is twice as the volume of oxygen. So, when electricity is passed through acidified water, it gets decomposed to hydrogen and oxygen. This kind of reaction is called as electrolysis of water. So, electrolysis of water is an example of decomposition reaction which takes place with the help of electricity. I hope you are following me. We are learning about decomposition reaction. There are three types of decomposition reaction. We already finished the thermal decomposition. This is the second one where the decomposition reaction takes place with the help of electricity. And when decomposition reaction takes place in water, it is called as electrolysis of water. Next, the third type, decomposition reaction also can take place in sunlight. For example, silver chloride, which is actually white in color, when it is exposed to sunlight, it changes into grey color. Note the color change. Silver chloride, when it is exposed to sunlight, changes into grey color and it decomposes to form silver and chlorine. Silver bromide also behaves the same way. When silver bromide is exposed to sunlight, it decomposes to form silver and bromine. Here there is only one reactant, two product, and this decomposition is occurred with the help of sunlight. And do you know where this reaction is used? It is used, or rather it was used in black and white photography. The film, the photographic plate, contains silver chloride, and when it is exposed, it is decomposed to silver and chlorine. I hope you have understood this decomposition reaction with the help of sunlight. Two examples, one is decomposition of silver chloride and silver bromide. White silver chloride turns into grey color, was used in black and white photography. So, here we finish three types of decomposition reaction. Before we go to the next type, please remember this is the third type of reaction we are going to learn. Previously we learned combination, then decomposition. Decomposition takes place in three ways with the help of heat. It is called thermal decomposition. When water is decomposed, it is called as electrolysis of water. Electricity is used to decompose water into hydrogen and oxygen. Decomposition also takes place with the help of sunlight. Example, we have seen exposure of silver chloride and silver bromide in sunlight, which decomposes to form silver and chlorine, and it is used in black and white photography. The third type of reaction are called displacement reactions. Let us consider this example. The reactants A and BC is a compound. Okay? What happens when A reacts with BC in displacement reaction? In displacement reaction, what you have to remember, or what is the key word for you or key point for you is, more active element displaces less active elements from its compound. Or we can say that in displacement reaction, more active element take the place of less active element in a compound. Let us see how it takes place. Here A is more active than B. So, A have taken the place of B, or A pushed B and have taken the place of B, and B is left alone. So, here displacement means changing the place. So, the more reactive element displaces less reactive element from its compound. Let us see once again. I hope you have understood. A displaces B and forms AC, and B is left. So, this is how the displacement reaction takes place. Let us see an example. Instead of A, we have element iron. Instead of BC, we have CuSO4. So, according to in displacement reaction, if it is to be taken place, iron should be more reactive than copper, and iron is more reactive than copper. So, iron displaces copper from copper sulphate and forms ferrous sulphate, and copper is left alone. I hope it is clear for you the displacement reaction. Once again, this element should be more reactive and the element in the compound should be less reactive. So, more reactive displaces less reactive element from its compound. You can see that a reaction when iron nail is dipped in copper sulphate solution. Copper sulphate solution is blue in color. When iron nail is dipped in copper sulphate solution, after some time, when you take out the iron nail and see, it will look like this. What happens? What is observation of this reaction? The blue color fades and the copper, the free copper which is deposited on the iron nail. So, the iron nail looks like this when it is taken out from the copper sulphate. So, let us see the reaction once again. Fe plus CuSO4 gives FeSO4 plus Cu. And one more thing for you to remember in displacement reaction, the reactant, there will be one element and one compound. Okay. This is also a key word for you to remember. One element will be there, another one will be compound. So, I hope the displacement is clear for you. Next, you can see some more examples of displacement reaction here. Zinc react with hydrochloric acid. Zinc is more reactive than hydrogen. So, zinc displaces hydrogen from here and form zinc chloride and hydrogen gas is evolved. The next example, magnesium plus copper sulphate. Magnesium should be more reactive than copper. So, magnesium displaces copper from copper sulphate and form magnesium sulphate and leaving copper alone. Have a look at the third reaction. Can you tell me what is the product here? Yes, you are right. There will not be any reaction in the third. Why? Why the third reaction cannot take place? Because copper is less reactive than iron. So, since copper cannot displace iron because copper is less reactive than iron, so here no reaction will take place. Remember, more reactive metals can displace less reactive metals from its compound. I was telling about the reactive metals, less reactive, more reactive. How are we to know which is the more reactive and the less reactive? For this, you need to know about the reactivity series. What is reactivity series? Reactivity series, in reactivity series, metals are arranged in the form of according to the reactivity. The more reactive elements, metals are placed at the top of this series and the least reactive metals are placed at the bottom of this. So, according to this reactivity series, which is the highly reactive metal, potassium, correct. Next, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, silver and gold. The least reactive is gold. Now, have you any time thought why hydrogen is a non-metal? Why hydrogen is kept in the reactivity series along with the metals? Because hydrogen is electropositive in nature. It can be displaced by a metal. That is the reason why hydrogen is also kept here. Now, you have a way to remember. Mnemonic is that for you to remember this reactivity series. Please stop calling me a zebra. Instead, learn how copper merely saves gold. Please, P for potassium, stop. S for sodium, calling me Ca for calcium, me M for magnesium, A for aluminium, Z you can remember zinc, instead iron, L for lead, H for hydrogen, C for copper, M for mercury, S for silver, gold. Please stop calling me a zebra. Instead, learn how copper merely saves gold. If you learn these, students, you can learn the reactivity series. So, this is a way how to memorize the reactivity series. So, we learned the reactivity series and we also learned a mnemonic to remember the reactivity series. Next, we will go to the fourth type of reaction, that is double displacement. Let us see how double displacement takes place. Let us consider these are the two reactants, two compounds. In double displacement reaction, exchange of ions takes place. So, how to understand this? Let us split these compounds into positive ions and negative ions. In standard 9th you have learnt positive ions are called cations and negative ions are called anions. So, let us split apart the first compound into positive and negative. So, A is a cation and B is an anion, positive ion and negative ion. Next, C is the positive ion in this compound and D is a negative ion. Now, what is happening in the double displacement reaction? Exchange of ions takes place here. Now, listen properly. Exchange of ions means either the cations should be exchanged or the anions should be exchanged. You cannot exchange a cation with an anion. You will end up with the reactants only in the product. So, exchange of ion either between the cations or between the anions. Let us see how the displacement reaction takes place. Here the cations are exchanged. Look at the product Cb and Ad. Now, we can understand more with the help of an example. Here it is an example of double displacement. The same way we will split apart this compound into two. Silver nitrate, Ag is a positive ion, nitrate is a negative ion. Sodium chloride, sodium cation and chloride anions. So, when displacement reaction takes place, there is exchange of cations. So, Na and silver, they are exchanged and in the product you get NaNO3, that is sodium nitrate and silver chloride. I hope it is clear for you, students. What you have to do first? Split the compound into positive and negative ions. After splitting into positive and negative ions, exchange the cations, either or exchange anions. Don't exchange a cation and an anion. So, here silver nitrate plus sodium chloride gives sodium nitrate and silver chloride. Let me explain this once again. AB is a compound, CD is another compound. Here exchange of ions takes place. You get the new compound, that is CB and AD. I hope it is clear for you. Here another example for double displacement reaction. CuSO4 plus H2S, we have split it into two, copper positive ion, sulphate negative, hydrogen positive and sulfur negative. So what you get? Exchanging of cations, you get sulfuric acid and copper sulfide, H2SO4 and CuS. So from these examples, what do we understand? What is called a double displacement reaction? Reactions in which there is an exchange of ions between the reactants are called double displacement reaction. Reactions in which there is an exchange of ions between the reactants are called double displacement reaction. I hope it is clear for you. Once again, we learned 4 types of reaction: combination, decomposition, displacement, double displacement. In decomposition again, with the help of heat, with the help of sunlight, with the help of electricity. Now, some of the double displacement reactions, there is a formation of an insoluble substance. So, the reactions which produce an insoluble substance, what do we call for that? A precipitate, are called precipitation reaction. Here it is an example of precipitation reaction. It is a double displacement reaction also. It is a precipitation reaction. Why? Because here this reaction produces a precipitate. What is the precipitate formed here? Is barium sulfate. What is the meaning of precipitate? Which is a substance which is not soluble in water, insoluble substance. So, this is an example of precipitation reaction. Barium chloride plus sodium sulphate gives barium sulphate and sodium chloride. Here also this barium is positive ion, this is negative, exchange of ions between barium and sodium, you get barium sulphate and sodium chloride. So, this is an example of precipitation reaction. So, what is called precipitation reaction? Reactions which produce insoluble substance, that is a precipitate, are called precipitation reaction. Next, in the previous session we have learned that chemical reactions can be accompanied by evolution of heat or absorption of heat. Based on this, based on the evolution of heat and absorption of heat, chemical reactions can be classified into 2, that is exothermic reaction and endothermic reaction. Exothermic, exo means out, to go out, thermic connected to heat. Heat is released in exothermic reaction, and in endothermic reaction heat is absorbed. Let us see an example of exothermic reaction. Take little calcium oxide in a beaker, add water slowly to it. After some time, if you touch the beaker, your hands will become warm. The beaker is hot. How? During the reaction, when calcium oxide dissolves in water, you get calcium hydroxide with release of heat. Heat is released during this reaction. Along with the product, heat is also released. That is why the beaker is hot and you felt warm when you touched the beaker. So, such reactions which occur with the evolution of heat along with the product are called exothermic reaction. You know, exothermic reaction, always the heat is written along with the product. This side after the arrow mark. If it is endothermic, it will be written before the arrow mark. So, when you look at this reaction, if you see the heat to this side, you can predict that it is an exothermic reaction. Okay? Along with the product, heat is also released. So, this reaction can be written like this: CaO, calcium oxide plus water gives calcium hydroxide plus heat. So, such reactions which gives out heat, which release heat, are called exothermic reaction. Now, there are more examples of exothermic reaction. 1. Burning of methane gas. When anything, methane gas, when it is burned, it combines with oxygen, produce carbon dioxide, water, and heat is given out. Next, what about respiration? Why do we respire? We respire to get energy. Now, how the energy is released? During respiration, the digested food, that is glucose, combines with oxygen. So, the glucose is combining with oxygen in our cells. When glucose combines with oxygen, energy is released, and the other byproducts are carbon dioxide and water. Since energy is released along with the product, we can also call respiration is an exothermic reaction. Glucose combines with oxygen in the cells and gives carbon dioxide, water along with the energy. Thus, respiration is an exothermic reaction. Decomposition of vegetable matter into compost is also an example of exothermic reaction. So, here we learned 3 examples of exothermic reaction: burning of methane gas, respiration, and decomposition of vegetable matter into compost. Now, next type of reaction is called endothermic reaction. During the exothermic reaction, heat is released. So, in endothermic reaction, heat is absorbed. And let me tell you, most of the decomposition reaction takes place by absorbing the heat energy. So, almost all decomposition reactions are the example of endothermic reaction. The chemical reaction which occur with absorption of heat are called endothermic reaction. Decomposition of ammonia. When ammonia is decomposed, it has to be heated. So, heat is supplied for the reaction to occur. So, heat is absorbed here. So, it is an example of endothermic reaction. The same with calcium carbonate. When calcium carbonate is heated, only when it is heated, it decomposes to form calcium oxide and carbon dioxide. That means calcium carbonate, to react, it has to absorb heat. Hence, in this reaction, heat is absorbed, so it is called as endothermic reaction. CaCO3 plus heat gives CaO plus CO2. Look at this equation, students. Heat is written along with the reactant. When you see an equation, the heat is written along with the reactant, it is endothermic reaction. When the heat is written along with the product, it is exothermic reaction. I hope you understood the difference between exothermic and endothermic. Now, since we learnt the main types of reaction, let us try to remember one key point for every type of reaction. We started with combination reaction. What is a key point to remember that? Only one product. The next reaction, decomposition. What is a key point to remember? There is only one reactant. Also remember, decomposition reaction can be taken place with the help of heat, electricity and sunlight. The third type of reaction we learned is displacement reaction. Which sentence we should remember this? More reactive metals displaces less reactive metals in its compound. Then we also have to learn the reactivity series. The next type, double displacement. Which sentence, what you have to remember? Just remember exchange of ions, exchange of either cations or anions. Next, we learn endothermic, absorption of heat, correct. Exothermic, evolution of heat or release of heat. So, endothermic, exothermic. So, today's session, what we have learned? We have learned about 6 types of reactions. We also learned about precipitation reaction. Okay? So, almost 7, starting with a combination, decomposition, displacement, double displacement. In that we learned precipitation reaction. Then we learned endothermic, exothermic. These last 2 are based on evolution of or absorption of heat. I hope this session is clear to you. Thank you, students.